Hello everyone, welcome to Spectra Education, and we are discussing about the surface integration of a vector field. In the last video lecture we have discussed, basically we have generated the concept of open and the closed surface, one-sided and the two-sided surface. Today we will discuss about the physical meaning of this surface integration. For right now things, this is a three-dimensional Cartesian coordinate system. So along this axis, this is the x-axis, this is y-axis, and this is z-axis. And there is a vector field. Let's say this vector field is like that one, a vector field which is xi cap plus yj cap plus zk cap. Let this type of vector field is there. Okay. And you all know what is the meaning of the vector field. And you can observe from the picture that at each and every point there is a vector. So collectively this is known as the vector field. Now what is the surface integration of this vector field? What is the physical meaning of that one? First let's try to understand that one. If we consider an arbitrary surface in this vector field, let's draw an arbitrary surface. So for example, let's say this is an arbitrary surface here. Let's say this surface is A, B, C and D, and this is a two-sided surface, and you must have the concept of one-sided and the two-sided. This is obviously two-sided surface. What is the surface integration of this vector field? We want to know that one. It means that physically it means that the net flux through this surface. What it means? The surface integration, the physical meaning of the surface integration is that, write down this one, flux of vector field through the given surface. Is it clear? So now let's try to understand what do you mean by the flux of a vector field. And I believe that you all familiar with the term flux from your school days, is not it? So let's try to recall that one. First I will explain what is the flux, what do you mean by the flux of a vector field, and if you can understand the definition or the concept of the flux, then this is nothing but the surface integration. So let's try to understand with an example which is very familiar to you. So to understand the concept of the flux, we have taken a very familiar example. So here let's think there is a positive charge, and we all know that the positive charge, there are field lines which are known as the electric field vectors. Is it clear? And we have considered a two-sided surface. We can think it is just like a plain paper, right? And here is a positive charge, and from the positive charge electric field vectors passing through this surface. Is it clear? And this is depicted here. So these are the field vectors, right, which is passing through this surface A, B, C, D. Now what is the, if this electric field is represented by E vector, what is the flux through this surface? What is the definition of the flux? Flux means that the total normal components through this surface. What is the flux? In general way we can write that number of field lines passing through this surface normally is known as the flux through this surface. Per unit time you can take. Okay. So number of flux, number of field lines passing through the whole surface normally. Okay. So first let's take what is the direction of this surface ABCD. Since area is a vector quantity and it must have a direction. What is the direction of this simple a plane sheet, what is the direction? That if we make a normal, outward normal, this is the direction of this surface. And if I consider a plane, it must have two surfaces. So a surface or plane must have two direction. One is the outer direction and another one we can think this is the inner direction, right? যে কোনো সারফেসের দুটো ডিরেকশন থাকবে, একটা হচ্ছে আউটার ডিরেকশন, একটা হচ্ছে ইনার ডিরেকশন। অ্যান্ড হাউ ক্যান উই ফাইন্ড আউট দ্য ডিরেকশন? ইউ ক্যান টেক এ পয়েন্ট especially at the middle and draw a normal. This is the direction of this surface. So similarly, what is the direction of this ABCD surface? If I take the point P here, right, if I draw a perpendicular, let's say this one, so this is the direction which is perpendicular to ABCD, which is the direction of this surface, or this vector represents the ABCD surface. Is it clear? We all know that one. If we think along this direction, along this normal direction, the unit vector is n cap. So what n cap represents? N cap represents the whole surface. Vectorially n cap represents this surface, because this surface is right now indicated by its normal. Is it clear? Now what is the flux of these field lines? That is, how many lines which are passing normally? You can see that what is the normal direction? This n cap direction is the normal to this ABCD surface. This n cap is perpendicular to this ABCD surface. If I consider one field line, let's say this represents this E field vector, is this field line normal to the ABCD? Obviously not, because this is along this direction and the normal direction of this surface is along this direction, so it makes an angle theta. So first what we have to find out? To find out the flux, first we have to find out the normal component of this vector, that means the component along this n cap direction. If we want to make two components of this E vector, the component which is along this n cap direction, this is the normal component of E vector. Is it clear? E vector এর যে ডিরেকশনটা n cap বরাবর, সেই ডিরেকশনটাই হচ্ছে E vector এর নরমাল ডিরেকশন ওভার দিস সারফেস। So what is the normal component of E vector? The normal component of E vector, so let's erase it, because in our flux definition we need the normal components. How many field lines passing normally through the surface? All the field lines are passing with making several angles, but we have to find out the normal component of each field lines. That means the component along this n cap direction. So what is the component? Component along n cap direction, which is the normal component of this E vector over this surface, which is nothing but E vector dot n cap. If we do the dot product of this vector with this n cap with the unit vector along this direction, this is the component of E vector along the n cap direction. So now if we consider an infinitesimally small, very small area ds, and this area is also represented by this n cap, because area is a vector quantity. How can we write this area, small elementary area? Ds vector is nothing but n cap ds. Ds is the magnitude of this area and n cap is the direction of this area. So if I consider an infinitesimally small area, then how many field lines passing normally, passing perpendicularly to this area ds is nothing but E vector dot n cap ds. What is it? It is the perpendicular, write down this one, perpendicular field vectors through ds area, through this ds area. This is the number, this is the total number of field vectors which passing normally of this ds elementary area. Now what is the then total flux through this surface? So if we integrate this one, it gives me the total field vectors which passing normally through this surface, and this is nothing but the flux. So we can write flux of E vector through the whole surface ABCD. We have to integrate this one, and this integration is not like a scalar integration, it is a vector integration, and it is not a single integration but it is a double integration, because surface area contains, it basically two dimensional, there must be x and y. So for that we are taking two integral sign. This is known as E vector dot n cap ds. What it is? It is nothing but the total flux through the surface ABCD. We have to integrate, we have to solve this double integration, and this integration is known as the surface integration. This is known as the surface integration. Integration of E vector, of E field vectors. Is it clear? This is known as the surface integration of a vector field. Here the vector field is E. What is the surface integration? This is the surface integration. And is it an open surface or a closed surface? It is obviously an open surface. So this is an open surface integration. We can also take another representation of the surface integration. So I'll write one by one. I think you have understood what is the physical meaning of a surface integration of any vector field. So surface integration of any vector field means we have to consider a surface, and through this surface what is the flux of that vector field is known as the surface integration of that vector. This is the physical meaning. Now what we have drawn initially, we have taken the F vector field and we have taken an arbitrary surface there, and there also this F vector field are emerging in different angle with the normal of the surface ABCD. Let's say this is the normal direction and unit vector along the normal direction is n cap. So then what is the surface integration of this F vector through this open surface, two-sided open surface, is nothing but surface integration F vector dot n cap ds. And we also know that ds vector, which is the elementary area here, is nothing but n cap ds. So we can write, this is equivalent to write that it is F vector dot ds vector. It also represents the same surface integration of the given vector field. And sometimes we are not using this double integral, but we would like to use single integral. So in place of double integration symbol, if you want to write the single integration, then you have to write this one. So this is equivalent to a single integration, but you have to write here S for surface. Is it clear? So let's check, is it visible or not? Yeah, it is visible. So surface, then either you can write F dot n cap ds, or it is same as surface integration F dot ds vector. Is it clear? So if this surface is just like a closed surface, then what will be the symbol for this closed surface integration? For closed surface integration, you have to make a round here. So it means that in a vector field there is a closed surface. You can think just like a balloon, okay? And if it is immersed in a vector field, what is the net flux through its whole surface of that vector field? will be represented by this symbol, closed surface integration, or if you want to use the single symbol, then you have to use this one, the single integration. Here you have to write the S, and then around it gives you the closed surface integration. So I think you have properly understanding right now what is the physical meaning of the surface integration. So directly you can use this formula to solve the flux related problem or surface integration related problem, or there is another working formula which is a fantastic technique to solve any complicated surface integration problem. So right now I will just write down its equivalent working formula to solve the surface integration problem. And in the next video, I will solve so many easy and hard type of problems and the previous year's problems, by which I think a complete knowledge or complete concept about the surface integration must be clear after solving several problems. Okay, so let's write down what is the working formula for this surface integration. So now I will discuss about the working formula of the surface integration. So for this case, let us consider a three-dimensional Cartesian coordinate system, and in this space there is a field, vector field A. I have taken only one vector to make it very simple, and I have also considered a two-sided open surface which is S, right? So according to the definition or from the physical meaning, what we have found out, what is the surface integration of this A vector field over this surface S, we can write it just like in double integration. A vector, if we take the normal of this surface along this direction, if we take this is the normal of this surface or perpendicular of this surface, which basically the direction of this surface, and let along this direction n cap is the unit vector. So surface integration of this A vector field is nothing but A vector dot n cap. And if we again consider a small area, let's take this area here. So let's take this area. Okay, this is ds. Is it clear? So then A vector dot n cap ds is the surface integration of this A vector field. We can convert this equation in a very simple two-dimensional case, because this surface is in a three-dimensional space. So for that, what we have to do? We have to first take the projection of this elementary surface in this xy plane. So if we want to project it, so I can draw several lines, right? So I can project this one. So these are basically, so this is the projection. This is the projection of this elementary area ds, and since this area is in xy plane, so its area will be dx dy, right? I will not prove that one, I will not prove the working formula, but I will write down directly and I will explain each term here. Okay, so this basically equivalent to, then this ds will be this ds. The magnitude of this ds basically, it is dx dy divided by n vector dot k cap, n cap dot k cap. If you need the proof of this one, you can do by yourself or you can write in the chat box. So this elementary area, when we are taking the projection of this elementary area in the xy plane, so this ds elementary area which is in this three-dimensional plane, this equivalent two-dimensional projection is dx dy divided by n cap dot k. N cap is the unit normal of this elementary area. And what is the k cap? K cap is the unit vector along the z direction. So then ds, we can replace this ds by this one. So this is right now the same surface integration, but this surface integration is right now in the xy plane. So it is in xy plane, right? So a vector dot n cap ds is equal to dx dy by n cap dot k cap. And when you will solve different problems, you will find that how much this equation is helpful to solve any numerical problems of the surface integration. So that's all for the basic about the surface integration, these two videos, the previous one and this one. In the next video directly I will solve several problems. So see you again in the next video.